In today's video, we will be discussing Physics 251, Week 8, problem number 55. In this problem, we are tasked with generalizing and solving for the maximum walking speed that a person can achieve using uniform circular motion. So if there's anything that's unclear throughout this video presentation, I would recommend going back to the Week 8 lecture and specifically looking at page 30. I think that will give you a good idea on what this problem is asking. So let's get into it. So I've gone ahead and drawn out a little diagram kind of relating some of the forces and the ideas in the write-up of the problem. So we have our length L right here, our leg. We also have our mass up here. And then we have our normal force coming up from the foot and our force due to gravity coming off of the mass. And this, of course, is just kind of being representative of our hips, if you will, and then this is our just whole leg generalized into one piece. So we have our weight, of course, and we have our leg length, and so a few important things to kind of keep in mind for this problem is Newton's second law here, as well as the equation for centripetal force, because we can use L in place of R, because we're essentially generalizing our leg to act as almost a circle going around a given point. So using Newton's second law here, we can set the centripetal force and mass times acceleration equal to each other. And from here, we can just kind of solve for velocity, which we will eventually solve for Vmax, but we can go ahead and cancel out the m's here. And then, of course, our velocity is going to be maximum when theta is equal to 0, so when the leg is straight up and down. And so our maximum velocity here then will be equal to the square root of g times L. And from here, we can kind of plug our values into the equation that we just got, g being gravity and L being the leg length here. So then we can get a maximum velocity of 2.62 meters per second, and then converting that to miles per hour using the just generalized conversion unit right here, we get that the speed is 5.86 miles per hour, or 5.89 miles per hour. So in the context of our normal walking speed given in the problem here, that last little n bit, this is reasonable. You know, it is a little bit faster than normal walking speed, but you have to remember that we've made quite a few generalizations about the leg movement. We have completely nullified the idea of there being any sort of bend joint in the knee right here. We've just assumed that the leg is one giant piece. So from that context, it makes sense, you know, because when we're adding the motion of the knee in here, that's going to take some speed off because it's just kind of added motion. But I hope you guys have found this problem helpful. Thank you very much for watching.